now let's go for the another group, that is a carbonyl group identification. The carbonyl group is nothing but a C double bond O. In this carbonyl there are two further differentiation, that is aldehydes. A carbonyl group at least one side if hydrogen is there, the other side you can have a hydrogen or any alkyl or any aromatic system, then they are called aldehydes. But one side hydrogen is a must for that aldehydes. For the ketones the hydrogen presence is not should be there, isn't it? So both the sides either alkyl only or one side alkyl, one side aromatic system, or both the sides aromatic also allowed, but hydrogens are not allowed. Both alkyl saturated system, aliphatic system, one aromatic, one aliphatic, or both aromatic allowed. Here one side hydrogen is a must, the other side you have an option of hydrogen, option of alkyl, option of aromatic. So this is a ketone variety. Here aldehyde, therefore both hydrogens, one aldehyde formaldehyde, one alkyl hydrogen acetaldehyde type, aromatic aldehyde benzaldehyde type. Here two alkyl acetone, one aromatic, one alkyl acetophenone type, both aromatic benzophenone type. So three ketones and three aldehydes are possible. So let us first go for the common tests. So there are some common tests are there. Both aldehydes and ketones both respond for this reactions and give. One is sodium bisulfite. A saturated solution you have to take, add it to the aldehyde, and both ketones both respond and to this reaction both all carbonyl compounds, both aldehydes and ketones will give a white crystalline solid derivatives. They are solids. Crystalline means they are solid with the crystals in fact. So clear crystals are formed when sodium bisulfite NaSO3, okay, sodium bisulfite, not sulfate. Sodium bisulfite dissolve in water, only limited water, saturated solution you will get. That saturated solution added to the aldehydes or ketones, immediate white crystalline solids are formed. You have a reaction with HCN, but derivative is not visible. With the naked eye you cannot find out any difference, so therefore that is not useful. But the test like a hydrazine, sodium, that is NH2OH, will get a white colored compound. Oximes are formed. So the derivatives are called oximes. And you have a hydrazine, NH2NH2, this is also a good test. Then you will get white color solids are formed, they are called the hydrogens. And you have a phenyl hydrazine, one side NH2 the other side phenyl, then also you will get the derivatives. You have a 2,4-dinitrophenyl hydrazine, NH2. There are two nitro groups are there at 2 and 4. This derivative reagent is also called 2,4-DNP, 2,4-DNP, 2,4-dinitrophenyl hydrazine is in orange to red color, reagent itself orange to red, dissolve in alcohol, then add it to the carbonyl compound, you will get a red color precipitate or solid derivative. You too have a semi-carbazine, that is NH2, NHCONH2. This also will give once again white color. So except this fifth one, the 2,4-DNP, all are giving white color derivatives. These are all common tests. Common tests means both aldehydes as well as ketones will respond to this one. Whereas there are some tests only aldehydes giving, only aldehydes, not ketones, okay, only aldehydes. That is, one is tolerance test. Tolerance test means a ammonical silver nitrate will give a silver mirror formation. Tolerance test means take only aldehyde, okay. Take aldehyde and then add the ammonical, this is Tollens reagent, you will get silver mirror formation. Silver mirror test, this test is also commonly known as silver mirror test. Inside the inner walls of the test tube you find a mirror formation, this is called silver mirror test also. You too can go for the Fehling's reagent, Fehling's test. Both Tollens and Fehling reagents are not ready-made reagents are not available. You have to prepare your own. Tollens reagent is take silver nitrate, add a few drops of sodium hydroxide, get precipitated to mud color, then add excess of ammonium hydroxide, a clear solution is known as Tollens. Similarly, Fehling A is copper sulfate blue colored solution, Fehling B is sodium potassium tartrate in alkaline medium, both you mix A and B, then Fehling reagent is ready. That reagent when you add the aldehydes only will give again the test, then you will get a Cu2O, a red color precipitate is formed, cuprous oxide, that is Cu2O. CuO will be there initially, that is converted to Cu2O in the Fehling test. Similarly, Schiff test. Schiff test you can prepare, but not for longer time, you cannot store. Once again, that is a para-rosanilin you take, dissolve in the acidic medium in water, and then pass the sulfur dioxide, you will get a clear solution, that is called Fuchsine solution or Schiff reagent. The Schiff reagent is colorless, but when you add aldehyde, immediately again pink color is formed. So, for the Schiff test you will get a pink coloration. This is the confirmation test for the aldehydes. You too can go for the Benedict's test, that is in lieu of this Fehling's test. Fehling's test will contain copper sulfate solution plus sodium potassium tartrate. In the place of tartrate ions, if you have citrate ions, the test is known as Benedict test. Again there also you will get red color precipitate of the cuprox. These three tests, if it is given by the carbonyl compound, it is aldehyde. Okay. These 6 tests are given by both aldehydes as well as ketones. A compound that gives white coloration with the hydroxylamine, but no one of these tests, therefore it is ketone. It gives this as well as Tollens, let us say it is aldehyde. Aldehydes are common test gives, and also aldehyde test also comes. Common test giving but not aldehyde test means it is ketone. So, if for a ketone is there any specific test, means actually for ketones there is no specific test, but for the specific type of ketones, that is a ketone containing one side methyl is there. This type of ketones, when you add a iodine in presence of a basic medium, this methyl group is converted to CHI3, which is a yellow color crystalline compound. So, this is called a iodoform test. The iodoform test is only for this type of ketones. Even here you can have hydrogen also, that is acetaldehyde also gives. Even all 2-degree 2-hydroxy, even alcohols also give. Therefore, in the case of alcohols, this test will become the iodoform test in fact. Alcohols can also be tested with the iodoform test, provided if they are 2-degree 2-hydroxy. In addition to the Lucas test, that is the concentrated HCl anhydrous zinc chloride, when you add it on the alcohols, all alcohols will give, but 3-degree 0 time, 2-degree 5 to 10 minutes, 1-degree very slowly, or on heating gives, that is another test for the alcohols we can use.